Hello, and welcome to our webinar on the latest research in the field of brain aneurysms. Today we are throwing a spotlight on the RAW study. RAW stands for Risk of Aneurysm Rupture. We know that in the UK there are as many as 2 million people, or 3% of adults, who are living with an unruptured aneurysm. Although most aneurysms are sporadic, meaning they are one-off events with no genetic link or family pattern, researchers believe that 16% of patients could have a strong family history, meaning that there is a genetic or hereditary risk. We also know that women are more at risk, 1.5 times more likely to have one, and that risk increases post-menopause. Despite all of these hard-to-hear figures and stats, what we know about the natural history of the disease, that means how aneurysms develop, when they appear, and why some rupture and others don't, well, that remains fairly limited. With society's increasing knowledge of genomics and science, the community of potentially 2 million people affected by brain aneurysms and their families are right to question then why our understanding of this devastating and costly disease hasn't progressed as much as other life-threatening but treatable conditions. The RAW study is looking to tackle these questions and more head-on. We are absolutely delighted to be joined by Professor Diederik Bulters, the Chief Investigator of the National RAW Study, who will share more about how the project and his dedicated team is working hard to unpack these questions, move forward our understanding of aneurysms, and ultimately improve patient care. Diederik, welcome. Thank you for joining us today, and thank you for leading what will be a transformational and urgently needed study. Please, could you describe the aims of the study and how you think it will impact patient care and future treatment?
Yes, of course. I should start by thanking you for this invitation. It's great to be talking about RAW. You ask, why did we start RAW? And at the core is the question that I probably have to deal with patients most frequently, which is, I've got an aneurysm. What are you going to do about it? And the question immediately comes up, can I have it treated? Should I have it treated? And that answer is not clear cut. And it probably differs from one person to another on their particular aneurysm and their particular health and circumstances. And to make that decision, you essentially need to know what is likely to happen to that person's aneurysm over the course of their lifetime, and try and make a personal prediction on that. And if their personal prediction is that this is a risky aneurysm, you probably should treat it. And if that prediction is this is not such a risky aneurysm, then maybe leave it alone, keep an eye on it with scans. The problem is that we don't really have any way of predicting what any specific person's aneurysm is going to do over their lifetime. And RAW is trying to answer that question in a nutshell.
And what does the timeline look like? When will that study translate into that more informed patient care and those patient discussions about when to treat and when not to treat?
So it's a big study. So it's of 20,000 patients, and it takes a long time to run a study like that. We've been going a good few years to collect all the information about 20,000 patients. That is really initially collecting what they were like when they were first diagnosed with their aneurysm. And then to find out what happens to those aneurysms over the years, we're linking those patients' records to national records of hospital admissions and deaths, for which the UK and the NHS has exceptional records. And so we're currently in the midst of that process of combining the data from over 20,000 patients together with the hospital records to see what's been happening to these aneurysms subsequently. We're hoping that we'll get that data back from NHS Digital, or NHS England as it's currently called, in the next month or two. And then there's a huge validation process to go through to make sure that all the records we've pulled and all the aneurysms that we've highlighted as potentially having ruptured, actually making sure that those records were correct. So that will happen over the next 6 months. And then there'll be about 6 months of analysis after that. So I'd expect around this time next year, to see the first results from ROAR.
And when those results come through, how long then before that translates into what sort of neurosurgeons are advising on to patients? Will that take another 6 months, another couple of years? How does that actually work from kind of research to sort of in the clinic?
Yeah, so translation into the clinic can take a long time in medicine, although this particular bit of research, it is an almost instant uptake. It's really all about getting people's awareness up and wanting to employ it. So essentially in a year's time, we'll have a tool where you can input a lot of details about any individual, and it will come back with an estimate of what their risk in their lifetime is going to be of their aneurysm rupturing, on which to make a decision. And that'll be instantly available. We'll publish it in medical journals, and we'll do a dissemination process, which we're hoping that HBA support will help us with. And I think within the UK, uptake should be pretty quick, because essentially pretty much every neurosurgeon involved in aneurysm treatment in the UK has been on some level involved in the study. So it makes it pretty easy to reach out and get to clinicians. Getting it through the wider medical community, out to the people who might refer to neurosurgeons, to the general practices, probably take longer, but hopefully the message will get out.
And that's remarkable, isn't it, that it's had such support from across all the neurocentres in the UK as well, and that it's one of the 20,000 sort of patient data people actually involved in this study is really kind of powering this study. Now, we're interested, as you know, in hereditary brain aneurysms and those with a family pattern. Do you think that this research will kind of pick up on that as a risk factor? And what do you think it will mean to those families who have hereditary brain aneurysms?
Yeah, so I mean, that's a huge part of the reasons for starting it. When I said at the beginning, the aim is to come up with some way of predicting for an individual what their risk is of their aneurysm rupturing. It's hard to really imagine that we treat somebody who has 4 relatives who've suffered from an aneurysm the same as somebody who doesn't have any relatives with an aneurysm. But that is currently essentially what we do, because we have no way of distinguishing how risky those aneurysms are. So the intention is that the main ROAR study, amongst the many factors it'll take into account, will be whether you have members of your family who've been affected. So that's the immediate ROAR study. We have lots of follow-on studies, essentially, or concurrent studies to ROAR, in which we'll get into more depth of specific aspects of aneurysms. And the big one I'm currently working on is ROAR DNA, which I don't know if you want me to go ahead and tell you a little bit about.
Absolutely. This is really an exciting project for everybody who has a brain aneurysm, but specifically for those where there is an hereditary pattern or a genetic link that we really need to kind of unpack. Please tell us more about it. I know this is a potential research project that you're securing funding for at the moment, but this really will be transformational, not just for patients in the UK, but globally as well. Absolutely.
So, what I was saying before is that we're going to try and use a family history. So just practically, do you have any relatives affected in ROAR? But that, of course, is a very, very crude measure. And really what you're trying to measure is what somebody's genetic makeup is. And the intention, therefore, is to try to write to all 20,000 patients to ask them if they would send a saliva sample back to us, which can be used to extract DNA nowadays. And then we can genotype them and try and work out which genes are involved. And the hope is that we'll get really quite a good return. We've piloted this type of work. We've seen returns as high as 47% from patients. Again, I have to give a plug that it's great to have people like HBA support advertising and trying to get enthusiasm for this in the hope that it motivates people to participate when the time comes. But we hope to have at least 6,000 patients who return a sample, maybe 8 or 10,000 if we get lucky. And that'll be by far and away the largest study of aneurysms or genetics of aneurysms to date. Previously, studies have typically had a maximum about 1,000 patients. And in genetics, because there's so many genes, you need a lot of data to try and nail down which ones are actually relevant. So that's what we're currently applying for funding for. And if that works out, yeah, we'll be writing all those letters in the next few years. There's quite a lot of work to be done for the genotyping, but you'd hope to see an answer in 4 years or so. And the answer would be two things. So the bit that links into the ROAR study that I've mentioned so far is to find which genetics predict which aneurysms will rupture. But probably more relevant to HBA support is the issue that for screening for families. So if you have a family member who's been affected by an aneurysm, lots of people will come and ask, yeah, should I be screened? Could I have an aneurysm? Am I more likely to? The reality is the majority of people will not have an aneurysm, but some will. And that probably will be obvious from that person's genetic makeup. And the hope is, therefore, at the end of raw DNA, we will have a genetic test to identify who's at risk and who isn't, and who should have scans in the future to look whether they have one or not.
And that genetic test will hopefully come through a blood test. So at the moment, if there is a risk, then you're advised to have brain scans and perhaps even regular brain scans, depending on how strong that family history is. But now we could be talking a sort of very simple blood test, which would then enable somebody to be on a certain care pathway or be told actually there is no genetic risk. And how do you actually see that kind of, again, appearing in the clinic and impacting patients?
Exactly that. So it'd be a blood test, one-off, and it would say you're at increased risk of this or not. And if you're at increased risk, you would end up in a screening program. And we have a screening program with scans currently, but it's very hard to target it to the right people. And you say it's quite intensive, both financially, time-wise for everybody, patients and clinicians. There's issues like at what age should you start screening? And nobody really has any strong data to tell you what age exactly aneurysms will start and what age you should start screening. But if you had a genetic test, you could just take it when you're young and not worry about it for the rest of your life. Once you go into these screening programs, you typically start with annual screening, then a biannual, slowly down to maybe 5-yearly screening. You might carry that on for most of your life. So cumulatively, that's quite a lot of time, effort, and cost that probably the majority of people could save themselves. And then for a minority of people, they could buy into that, possibly have more intensive screening because you've now focused it down to a more specific group of people. Currently, screening is offered in where families have a strong family history. So say, well, the criteria is usually 2 or more first-degree relatives, and first-degree relatives is parents, brothers and sisters, and children. And that's actually quite a hard criteria to meet because children don't generally have aneurysms because they're too young to get them. Birth rates are not that high in this country, so people don't have that many brothers or sisters, or might be an only child. And parents have often passed long time ago when medical records weren't so good and information wasn't necessarily available. So actually, the astounding figure that I've worked out in recent times is that probably only a very small percentage, 5 or 10% of people who actually have a genetic risk will actually have any awareness that their family have that genetic risk or somebody has an aneurysm.
So that's a large community then that could potentially really benefit from having sort of a genetic test, and also the greater understanding of aneurysms and the genetic foundation of them. But as well as screening and the doors that this study will unlock, is there also an opportunity to change the way we treat these as well? You know, we've heard a lot about cell and gene therapy and different drug therapies as well. Is there a time, sort of in 10 years, 20 years, when actually we could be looking at different treatments rather than sort of coil stents and clips or a watch and wait? will this or could this unlock different ways that we look and treat aneurysms?
Yeah, there's two different timelines on that. There's a will and a could. So the short-term will change is that understanding the genetics of what causes an aneurysm will probably unravel some of the mysteries we have, such as what you mentioned earlier, that they're much more common in women. And there has to be a biological explanation for that, and it's very likely that that biological explanation can somehow be exploited to reduce risk. There's also lots of putative things that might make a difference. Aspirin is a classic one that people talk about. Some people think it increases the risk of an aneurysm rupture. Some people think it decreases the risk of an aneurysm rupturing. One direction, because aspirin slightly thins the blood, so there's a worry that that is worse for bleeding. On the other hand, aspirin reduces inflammation, and it's believed that inflammation might play a role in aneurysms forming. So there's lots of things that are actually common in daily life that will probably get insights to whether they're good or bad, that you could employ pretty quickly after a study like this. Then longer term, the things you're talking about with cell therapies, genetic therapies, yes, I think if you understand the genetics, then sooner or later those things will become possible. They're long horizon things though. But that is the long-term future, I think.
And the guidelines, which you mentioned as well, the 2 or more first-degree relatives. Do you think with our increased understanding of aneurysms with the raw study, but then even further still with the with the raw DNA study, that actually the guidelines will have to catch up with the science and our improved knowledge?
Yes, definitely. So I would anticipate that the initial ROAR study will just give us a much better feel for how you can quantify how many family members you have and how big a risk that is, and therefore whether you should be screened. But then raw DNA will completely change it, because almost certainly, in due course, you won't go based on family history. You'll simply go based on what your genetics are.
So again, timeline there could be variable depending on what you find. And tell us a little bit more about the kind of the team that is working on the raw study as well, because that, just going back to that, that's happening right now. That's a fantastic piece of work. 20,000 patient records that eventually will be looked through as well. How is that going? How is that going to kind of extrapolate all the data that you need? Any surprises coming up there?
In terms of the process of doing it?
Process and findings.
I think you first asked about the team. The team is enormous, and it's been an amazing experience working with so many, predominantly neurosurgeons, to make this happen. So we try and keep a list of everybody who's involved and include it in our slides, but it's pretty hard to fit onto a slide these days. There's at least about 50 neurosurgeons across the country, and then with those consultants, each one will have probably about 2 or 3 juniors who've been working with us. It's a huge effort, and then coordinated by some extremely hardworking fellows with me in Southampton, and then support from Oxford with statistics. So it's a huge team effort. Been amazing. And it's been amazing to see it work, is the honest truth. I do a lot of research and have done so for a long time in aneurysms and subarachnoid hemorrhage. And it's the first study, I think, that has ever recruited more patients than we anticipated. The plight of most researchers is always things going slightly less well than you had originally planned. And so usually in research, you have to write a full documentation of what you're going to do, how you're going to do it, and when you're going to do it. And you look back at these things and go, oh, didn't quite work the way we wanted. But this one so far, pretty much every step has outperformed what we'd hoped for. So it's been an amazing experience.
And I suppose any kind of surprises in terms of those kind of risk factors, or anything that you think, we weren't expecting to find this in the data, or this is perhaps coming up stronger than we expected to find in the data, or is it too early and you need to do more analysis on that?
Well, purposely in these studies, you try not to look at the data too much as you go along, or at all, because it makes you change how you interpret it. And it risks you developing all sorts of biases. So I've got no insights to the big answers that we're trying to ask. I guess what are the insights we've had so far? You can look at what the population of people going into the study were. So that's one component that where we sort of looked at. Is it a surprise? I guess one of the bases of why Britain is the right place to do this study, because Britain has relatively low treatment rates for aneurysms. And the more aneurysms a country treats, the less information there is for a study like this. And so that's worked out pretty much as we had anticipated. So, we treat in the study, I think 25% of patients. I think in America, it's about 75% of patients. It gives you an idea of the issue, of the controversies and difference of opinion of who and how many people should have their aneurysms treated. So I guess that's probably the most insightful bit of information we've had from it yet. But as I say, it's not a surprise that we haven't seen too much. It's intentional.
And I suppose you've touched upon there the different opinions, and that's something that kind of we hear about from patients directly, of a neurosurgeon here believes this, a neurosurgeon here believes that, or advises this, advises against that. Again, it's the RAW study hoping to perhaps answer some of these questions, so there is more a sort of a definitive guide and a definitive answer to the many questions that we get from patients. As when you start screening for children, when you start screening for this relative, and is it hoping to kind of get, if you like, to a more uniform standard of care, while at the same time keeping in mind the unique sort of medical history and family history of patients?
Yeah, I hesitate slightly with the word definitive, because it suggests that we would be dictating what should happen. It should give you a definitive answer whether your risk of your aneurysm bursting in your lifetime is higher or lower than the risk of its treatment. And that's how clinicians look at it. Ultimately, of course, it's for patients to decide how they want to work with information, and different people have very different tolerances of risk. So, the most pragmatic, real-world way the data will work is that it will tell patients what their risk is and allow them to choose how they have to proceed.
Yes, absolutely, and it's that joint decision making as well, depending on where people are in their life journey, and also what they've been through to get to this point, because there's so much fear, isn't there? So much fear and anxiety around aneurysms, and I suppose why we're so excited about this study as well. It's somebody who has lived with an aneurysm, somebody who has had an aneurysm treated 6 years ago, is that it is hoping to fill in those gaps, to kind of answer some of those mysteries, so we can make sort of those decisions that are right for us at the time, because we may change as our life continues as well. But just one final question on the raw DNA, if you don't mind, if we can just switch back to that. Again, we hear from patients who have aneurysms that sometimes there are also aortic aneurysms that run through the family, and there are also different conditions. We know that PKD is associated with aneurysms. Will the raw DNA study also help, if you like, answer almost these secondary questions of what else is happening, or what else could be connected? What else could be connected in that kind of vascular world as well? Is it hoping to kind of shed light in different areas to increase our understanding of our complete health?
Yeah, it's going to be by far the biggest data set about aneurysms in the world, by a factor of 10. And it is essentially going to bring big data to aneurysms and try and answer all these different ancillary questions. To tackle the two examples you gave me there, aortic aneurysms, I'd probably give a bit of reassurance straight off, because that's one where we probably already know that aortic aneurysms running in the family doesn't really relate to brain aneurysms. So although they have the same word, they're pretty unrelated. And we'll have data from RAW on this, but I don't think it'll change that. Polycystic kidney disease is really a very central part, actually, again, of RAW. And I should acknowledge the kind funding that actually really got us started from the PKD charity to try and increased the number of patients with PKD in the study. And actually the study size was specifically designed to be confident that we would be able to answer the questions for PKD patients, which again, probably the big one there is, so just for people who are not familiar, PKD is polycystic kidney disease, and aneurysms are much more common in those patients. Probably maybe 20% of patients will have them. But we have no idea whether those aneurysms are more risky or similar in risk to other aneurysms. Actually, most of the data suggests that they're similar to other aneurysms, but it's very counterintuitive. And it's always quite worrying to tell somebody who's got lots of relatives who've had aneurysms, don't worry too much about it, that you've got other relatives affected. The data seems to suggest they're not particularly dangerous. But so ROAR will definitively answer that for PKD patients. And so, as you say, there's lots of other related conditions that we'll look at in detail.
This is incredibly exciting. So thank you so much for taking time out of your very busy day to join us today, so we can find out more about ROAR, but also about raw DNA, which is potentially coming up. And I hope you will join us again very soon when we have first results from ROAR, and perhaps we can go into a little further depth about raw DNA as well. And I'm sure we'll have lots of questions from our community as well. So thank you so much for joining us today. We really do appreciate your time. And thank you all for listening in and for joining us today. And we hope that you have found it interesting. And please do take a look at our website for more information. And on there, you'll find more information about the RAW study and the RAW study pages as well, where you can go into lots more detail. Thank you, Diederik, and thank you everybody for joining us.